Seismic vulnerability analysis of reinforced concrete frame with infill walls considering in-plane and out-of-plane interactions. Based on the test data on masonry infill walls, this paper designs a performance indicator for infill wall in the light of IPOOP interactions and determines the response threshold of each damage state. A 5-story infill wall RC frame was designed using PKPM, and 2 3D space models were established for the structure, with and without IPOOP interactions, respectively. A total of 20 ground motion records were selected to conduct an incremental dynamic analysis, IDA, on the prepared structure. Under the ground motions of the same intensity, the frame with infill wall IPOOP interactions suffered greater lateral deformation than the structure without these interactions. Figure 6 indicates that for any damage state, the IPOOP infill wall was always damaged earlier than the IP infill wall. With the rising degree of damage, there was a growing gap between the ground motion intensities required for the two models to reach the same damage state. The effects of IPOOP interactions on the vulnerability of infill walls can be maximized on the mid-stories of the structure, and may cause damage to the infill walls in these stories. As can be seen from the vulnerability curves, the consideration of infill wall IPOOP interactions can enhance the damage probability of the frame with infill walls. The enhancement was the most significant for the moderate damage to partial collapse state of the structure.